know it's after lunch, so I'll take it easy. Please don't fall asleep. I know the seats are really comfy. Thank you for coming. That's a lot of people. Great to see you here. So welcome to my talk. Welcome to Google Assistant Smart Home API in practice. How many of you, show of hands to get the blood pumping, how many of you here have a Google Home Mini, one of those devices at home? Oh, wow, keep them up. Lower your hand if you have not created any actions or any code for your devices. Okay, so a few of you have done, okay, that's very useful, thank you. So a few of you have dabbled with actions in Google, but most of you haven't. So I hope this talk is useful for this. So thank you for coming. My name's Orestes. I'm a full stack developer. I started coding a long time ago, and I'm a community lead, mentor, author, very big into metal, heavy metal. And down here, you have my Twitter. It's going to be here during the whole talk. If you have any questions and at the end you want to ask them, or if you want to ask them in private or ask them on Twitter, use that for the questions. You can also use my Twitter to send me pictures of cats. Here's mine. He's super cute. This picture was taken in Galicia, where I live. I live in the northwest of Spain. It's a great place to live, very cozy, and we have a lot of community. In fact, we have so much community that we have a community cluster, which is something that I think we were the first in Spain. I've never heard of this idea before, even though other people tried it. So basically, a community cluster is something that most cities could probably use. It's basically just a website with a calendar and a directory of all the different meetups that we have, and we share this common identity of Vigo Tech. That is a lot of events for a small city like we live in. And I'm part of the Google developer groups of Vigo, which is one of the main cities. And if you haven't heard about GDG, the Google Developer Group, it's a program we have a lot of different chapters here in Spain. Probably if you live here in Spain, you've met anyone from GDG. In fact, it's a very big worldwide program. I think we are over 1,000 chapters at this point. At the community booth, we have a booth for the local GDG. We're giving out T-shirts and stuff like that, so come and learn about the different chapters, the different events that we do at GDG. You'll be more than welcome. And I gotta eat. I gotta keep myself fed up. So I have to work doing something. I love doing software. So a few years ago, we started a consulting company. It's based in Texas. It's fully remote, fully distributed, which is the cool way to say it right now. So I work from here as another guy that works from Madrid, as people traveling. It's very cool. And we mostly do software consulting for projects with lots of data. I'm not going to say big data because there's a lot of experts here. We do stuff with lots of data. If we've done stuff with data from the Department of Defense of the US to figure out if they slice the budget or they increase the budget in certain places, how does that translate to specific jobs that are gained or lost in specific counties and even zip codes. So we do all the data visualization, cool stuff. And one of the clients that we had a couple of years ago came with this idea for something that had a different name, and now it's called Navigo. And Navigo is another software company, another product company that we started, which is really useful. And what we do at Navigo is we watch over people that travel abroad. Mostly people that are in some kind of humanitarian mission, relief mission, in different countries where it's usually not the safest place. So we have this model of the world with different impacts in different regions, and we watch different sources, and we can protect people before something happens or react very quickly to it, because sometimes in these places, the news, they don't travel very fast. So while working on this, I realized the use case for the families of the people that were traveling, the use case was a little bit complicated. Maybe you had a person that was a little bit technical that was traveling abroad, and their people, their family home was wondering, hey, is my significant other okay? Is my brother okay? What's their status? Where are they? And they have to have an account, log in, go to the dashboard, look for the specific person, or go to the profile. And that felt like a lot of a hassle for something that could be done with tools that we have now. So I bought one of these on Google Home, and then they came out with the Google Home Mini, so I bought another one of those. And then they came out with the Nest Hub, so I had to buy another one of those. I hope they don't keep making them. But basically what I wanted to do is have a voice interface for those kind of people, for the family. So you could wake up in the morning and ask Google, hey, is my brother okay? How is he doing? And that's how I started going down this rabbit hole of voice user interfaces. So all of those devices, those are input devices, ways of communicating with the Google Assistant and the Actions on Google platform. You don't only have them at your home, you can have them on your phone. Even if you have an iOS device, you can download the Google Home app and you can just use it. You can have it on your smartwatch, and you can have it in your car. There are cars now that come with the Google Assistant, which is pretty cool. There's a bunch of other devices that work in the Google Assistant platform and other voice user interface platforms. And this image is from like 2 years ago from the Google I/O, so that number is probably tripled or quadrupled over the years. But what's important is all these devices are, you gotta look at them from the other side. So for example, if you buy one of these light bulbs, somebody made it, and somebody made an interface. So when you talk to Google, that light bulb understands that. And that was a very interesting problem to me, so I said, okay, I'm gonna just make one of these. And this is what we're going to see today. So I couldn't bring my apartment, it wouldn't fit in my in my luggage, so I brought a small Lego home. There's a light in there we're gonna be using for the demo. If the demo gods, are with us, it'll work. So this is what we're going to do today. We're gonna go through the process of creating a smart light bulb and understanding how the Actions in Google platform connects to whatever it is that you're using to drive your own hardware. So this is very useful if you're a creative person, if you're a developer that is looking for other projects, other ways to waste your weekend or lose a couple of hours of sleep. That is very interesting. Just as a note, there's not a lot of code in this presentation, but all of this code has been published. I'll link in a tweet when I'm done. And there's also a whole workshop that you can follow with a list of materials to build a specific light bulb. And I'll tweet that as well. So if you want to follow, this is a home, that's a good opportunity. So what we're going to do to learn about this makeshift, make-believe smart light bulb, we're going to have a tiny bit of introduction to IoT, not super in-depth. We're going to talk a little bit about how the Actions on Google platform works and how to set up a project in the Actions on Google API so you can use the smart home API. And then we're going to see a demo at scale. So first of all, who here has heard of the Internet of Things, the IoT? Pretty much everybody. This is very, very common nowadays. So just as a small recap, the Internet of Things is this new paradigm of computing. It used to be that computers were the size of entire rooms. They were really, really big. They got commoditized. They got to their homes of the users with the personal computer era. Now we got the revolution of the internet. Everything is connected, and then the computing got even better, even cheaper. And now computers are like really, really tiny. When you're done, if you want to see what we have here, it's literally a chip this big. It's really, 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 really tiny. So now it becomes really, really easy to deploy all kinds of devices and sensors and actuators and gather information from the world. And if something breaks, you can replace it very easily. So that is basically the world we're living in. And it's a great platform if you're a creative developer, a creative person. You can do whatever you want to do with electronics. It's really good. If you've never gotten started with electronics, there's a bunch of kits that you can buy for Arduino and for other open hardware platforms. They are very, very cheap nowadays. They used to be kind of expensive. And this was the first demo that I did. I was super, super proud of this one. Hello? Okay, well, the video won't play, but I'll tell you what it is. It's basically the Knight Rider example. Oh, there we go. So it's basically the Knight Rider. You remember Michael Knight. I was super proud when I coded this for the first time. I sent an image to my dad. It was like, hey, look what I did. And he basically said, yeah, that's cool. Pick me back when you can talk to it. So now I can. Ha! Take that. You can also do actually, useful stuff. This is a robot that argues with people on the internet, you know. If you have an issue with somebody, you can use the robot to leave a very thoughtful comment. You know, it makes your life easier. And, you know, but while doing stupid stuff and doing Night Rider and doing small projects and all kinds of speakers and squeaky noises and servos, I realized all of the stuff and all of the skills that I picked up, they ended up translated into my job. I was a software developer. We did mostly web stuff. And we had a client, which was the town hall in Barcelona. And we had this kiosk. You've probably seen them on IKEA if you want to get a IKEA credit card and give them all your data. You have these in Barcelona. And basically these are so you don't have to go to the town hall and get an appointment if you want to do a bunch of paperwork that can usually be automated. You can go here, just put down your ID on an ID scanner that we have, and do a bunch of stuff that usually, you don't even need a person. So if you want to do that on a Sunday or, whenever the town hall is not open, you can do it. So that was a very interesting project. It's also very cool, and a very common problem for the everyday citizen. But we had an issue, and the issue is, the users are not always the smartest. And there was a problem with this kiosk, and it was on the document reader, which is this black box here. There was a point where the user had to, identify themselves. And we will flash a message on the screen and say, please insert your ID on the scanner. And people took this as, okay, I need to insert this somewhere. They will look for a gap somewhere in the metal for the kiosk, and they will jam their ID inside of the kiosk and say, it doesn't work. And they weren't using the black box that was designed for that. So, somebody had to come with a key, open the kiosk, retrieve the pile of IDs left over. It wasn't fun. So we were tasked with solving this. And if you ever worked in this kind of kiosk environment, you know that what's actually running behind that, it's actually just a website. And what's even more bothering is the engine is usually Internet Explorer, and it's a very old version of Windows. So what they wanted to do was, hey, we want to add LEDs, so when we tell the person, put your ID here, we flash them, like here, like, when you go to the airport, you see the people with the signals, that kind of stuff. The problem is if we add an LED strip, how do you even turn that on from a website? You cannot do that. Today we have web USB. You could do that with a USB relay, but a couple of years ago we couldn't. So since I knew a little bit of electronics and a little bit more about web development, I came up with this idea. Basically, I created an ActiveX control. Yeah, I know. Written in C# that was registered in that Internet Explorer, and that provided a JavaScript interface to the USB. And I did that because I knew I could. If I wasn't tinkering with Arduino, I couldn't have done it. So we deployed it, it worked, we solved the problem, yay. And good point for playing with electronics on the weekend. That was a very helpful experience. So today, the software is very, very advanced. The hardware is a lot cheaper. We're gonna be using one of these devices. It's probably something that you've heard about before, is one of these chipsets. There's a new version. They're really cheap. You can get them for like $3 from AliExpress. They have built-in Wi-Fi, which is like a miracle. And you can use a tiny battery, use the Wi-Fi, and go to town, do whatever you want to do. I'm also using one of these LEDs. If you tinker with electronics and you've used LED, RGB LED, you have like different pins for different colors. It gets kind of confusing. It's not super straightforward. These ones are very, very easy to use. So look into the NeoPixel from Adafruit. And this is basically how it's going to look. The initial prototype of this is, hey, I want to make something that connects to the internet, and I can ping a specific API and use a RESTful API and tell it, turn it on, turn it off. So that's how we build this thing. We do it in incremental steps. So for the first step, I just end up coding a small RESTful server inside of the microcontroller. And when you hit the send point, for example, you just give it a command, turn it off and turn it on. That's basically the first system. Then you need the other system, which is how do you trust user voice? How do you understand user voice? How do you extract intent? What do they want to do? So for that, we have the Actions on Google platform, and there's basically 3 different components. The first one is the device that you're using to talk to the Actions on Google platform, and that's your phone, your Google Home, your Google Home Mini, your car, if you happen to have a car that has the Google Assistant. There's the Google Assistant itself, which is the primary interface that you go through, and that connects you through the user-submitted applications or company-submitted applications. And those are called Actions, and the operating system that they use to run is called Actions on Google. That is the platform that contains the API that we're going to talk about. So let's say we're building just an app to talk to and to do some voice interaction. Let's say it's called Flip-Flop. And because I like to go, wherever I go, I like to use flip-flops, not today. So I want to know if it's cold or it's hot enough to use them. So I can build something that works a little bit like this. You ask Google to talk to Flip-Flop, which is the app that you created, and then the Google Assistant takes over. It takes a look at all the applications that have been submitted by the users, finds one that's called Flip-Flop, and pings it and says, hey, application, somebody wants to talk to you. Please give me some text so I can respond to the user. From that moment on, you're no longer talking to the Google Assistant. It's the application replying through the Actions on Google platform. So everything happens kind of normally. These programs used to be super hard. Doing text-to-speech, maybe not so much. Doing speech-to-text used to be very, very complex. Now this is the services provider for free. It is really, really easy to work with. So let's say that the application responds, hey, how can I help? And I tell it, I wonder what I should wear today in Madrid. And it's going to tell me, oh, it's kind of cold in Madrid. You shouldn't wear the flip-flops. And that's it. And you'll notice there's a couple of words there in bold, Madrid. That word is something that is going to change from conversation to conversation. Another person could be using that in a different part of the world, and my application will have to know, oh, I have to fetch the temperature for this other city. Otherwise, it's going to be flip-flops for Madrid only. So that is what the Actions on Google platform does for us, and what other tools like Dialog that Google provides for us. That's what they do. They help you extract user intent, and they help you extract those entities, those different pieces of data that are going to change in the different points of the conversation. So with those pieces, how do we go about building an experience for a smart light bulb? For a smart light bulb, you have a lot more intents. You have somebody that wants to turn it on or off. On and off, maybe that's one of those variables, but the intent is, I want to change the power state of the light bulb. Another intent is changing the color. I want it in a different color. And then the color will be another entity. And then the intensity. I want it, a little bit more intense, a little bit softer. Again, you have another entity, and you have another intent. So this gets kind of complicated. And if you do this for a bunch of devices, you're going to realize you're going to build an Actions on Google that has to take into account a bunch of different phrases, a bunch of different ways to ask for the same thing. And that will take you quite a while to develop. But luckily, you don't have to do that because Google did that for us, and that's why we have the Smart Home API. So the Smart Home API knows about pretty much anything you can think of at the device. You have definitions for starting, stopping, turning on, off, changing color settings with different color schemes, changing brightness, changing speed, you can do pretty much whatever. Up until a few months, maybe a year, there used to not be like an open close. For example, if you had a door, like a garage door, they used to not have that, but they added it. And they added it in a way that you can control, let's say, like the garage door. Open the garage door to 50%. Now you can do that. So it's not a stale API. It's something that is being worked on actively, being improved actively, and now it's a great time to get started with it. So you get that voice interface and all of that tremendous work that you will have to put to understand what the user is doing, but you also get a GUI. You get an app, and this app works in iOS. It works in Android as well, and you get an interface. If you can see down here, like I have an on-off button physically on my phone. I can be in a different room, open the app, and just click that button. If I don't want to wake up my girlfriend by talking to the Google Home, for example, you can do that. Imagine creating a UI for every kind of device that you have. Again, that's a lot of work. You don't have to do it because Google did it already. So that's great. So how does it work? So it's 2019. Everything is a graph. Behind the scenes, you might be talking to the API. What's behind the API is a graph. Everything is related, and this is no exception. Google has this thing called a home graph, where it stores all your devices and the state for those devices, and it knows, what they're doing and how are they organized. So, for example, you can see here. This is a screenshot from the Google Home app. You can see there's like a name for a home. So there's a concept of a home, and you can have more than one. So this one is called Toy Home. Then you can see there's a concept of a room. This one is called Downstairs. So you have that concept as well. And the different devices that you can have home, they also know, if you have a Google Home in your kitchen, you tell it, hey, this is in your kitchen. Later, if you add a light bulb, you can tell the Google Home app, this is in my kitchen as well. So when you enter the kitchen and you ask Google to, hey, turn on the light, Google knows, hey, I'm in this room, there's one light in this room, I'm gonna turn this one on, not all the other ones in the home. So that is pretty useful. So here in this example, I only have one room that's called Downstairs. And the way it works, the interaction is slightly different. You don't have to code anything on the Actions on Google platform. You just have to code the interface. You have to code the connecting API between the Google Assistant, the Google Smart Home API, and whatever your platform is. In my case, it's something custom that I made, but you might be connecting to, I don't know, something from another manufacturer. There are a lot of pretty cheap manufacturers for the smart home appliances. So let's say that you ask Google to turn off the light. It's gonna use the information in the home graph to do that, figure out which light it needs to do that. And behind the scenes, it's gonna send an API request with a very specific format that we're gonna see to the device provider for the provider for that specific device. So you, on the other end, are gonna get an HTTP request. So the way I build this is I have a little bit of Nest code, which is a great framework. I have a UI that you use as well. You usually, let's say you buy a smart light bulb, you need to give it a name. You usually have some kind of UI to do that, to configure it. That is done with Angular in this case. And then you have the API part, the part that Google is going to ping. And that needs to provide an OAuth interface. This is pretty familiar for most APIs. And it's gonna do the intent handling. When Google sends you something, this API needs to understand what Google is asking and ping this device and tell it to do it. And it also needs to provide proactive updates. So there are a lot of devices, like for example, a light switch, that a user can interact with directly. You can go and turn on the light switch. You will have to understand that the user is doing that and ping Google and tell it, hey, somebody changed the state for this light. Otherwise, when the user goes back to the Google Home app, this state is going to be inconsistent. Or Google is going to ask about, how's that light doing? So you need to provide proactive updates. So for the Smart Provider Home UI, you have the user registration and authentication. For that, I'm using Firebase. It's really easy to set up. And then the device management, adding another light bulb, adding another door, adding another camera, whatever it is that you're doing, you usually have to configure it on some kind of web interface. And this is the dialogue. This is what you talked. This is what Google tells you. This is the way Google communicates with you. There are a few different intents that happen in a different point. So, for example, sync happens when somebody connects their account for your new provider. So let's say you are creating something that's called Toy Home. So in my case, it's called Toy Home Provider. Google is gonna, when somebody adds that to their Google Home app, you're gonna get a request. Hey, this user is using your platform. Tell me about all of their devices. So you need to have a list of those devices and give them to Google. The query is, like I said, when Google wants to know the device state for a very specific device that you have. Execution is when you do something with your voice, like, hey, change this light to this color. And disconnect is when somebody disconnects their account. So they all look like this. Since you're using OAuth, all authentication is provided by that middle layer on your API, so you don't really explicitly know which user you're talking about. You have to extract that from the token that is coming from Google. So all the requests look like this. You have a request ID, you have inputs, which is an array. Usually you only get one action, and in this case, Google is asking me to, hey, give me some information about a specific device. So just as a small recap, this is what happens. Everything that you do with Google that ends up in the Smart Home API ends up being an HTTP request. You have to figure out what Google is asking of you, and then somehow pass that on to your devices. So it's very easy to set up a project. Basically, if you're used to this screen, you create a project. Instead of using the regular templates, you need to use this one, that's the Smart Home. And in here, you need to give it a name. This name is not something that you say out loud, even though, for flip-flop, for example, that will be something you have to do. Not for this one. This is just going to be on the list. This is not something you need to say. And here, if you've created actions on Google before, usually you have for every different intent, you have a different action. For the Smart Home API integrations, you have one single action, and it is called actions.devices. And you also see, if you use Dialogflow, for example, you can see that the fulfillment tool is not Dialogflow, it's the actions console. So you need to give it the main URL for your API. What are you going to be using? In this case, I'm going to be using local tunnel, or I will be using local tunnel to create a tunnel from my local code to the internet, so I don't have to redeploy everything every time I want to make a change. And then you need to set up account linking. Account linking is the way Google links users. Sorry, Google. Is the way they link users to those tokens that they're going to be using with you. So you provide some basic credentials. Google is going to be using those every time. It's going to handle it. If the token expires, they're going to renew it. They do all of that for you. So on the API, I'm providing a couple of endpoints, one for the token, that's where the auth authentication happens, the one for the actions, which is the Smart Home one, and that is the endpoint that all the actions are going to hit when the user is talking to Google, asking it to do something with my devices. And then I have an extra one for just to redirection. If for some reason, I need to change something to a different server, I don't have to go back to the project and change the URL again. So this is how it looks like, how it looks in your app. You start with no devices, you go to add a new device, you tell it, hey, this is something that already works with Google. And if you see on that list at the very top, it says Stay Home by Orestes. That is the name that I gave it at the beginning. Just as a funny thing, you can see that it's like alphabetically ascending. People figured it out, and now there's a bunch of providers that are called star whatever, underscore whatever, 0 whatever, because they want to be at the top of the list. So that is interesting. So this is just an overview of how the account linking works. I'm going to skip it because it's kind of boring. Again, kind of boring. We're going to do a demo in a second. This is what we're going to see. I'm going to connect to my phone right now. I'm going to share the screen, but this is what you will see. I have like a little bit of a debug there that tells me which get params I got, and you can see Google tells me, hey, there's a specific state. I know this is one of the users from Google. You need to authenticate them with this state, and when you're done, please redirect them here. So I'm using Firebase. When I log in with that user, I just do the redirection. And immediately in this screen where it says linking, that is when I get the first request, when Google says, hey, send me all of the devices for this user. And in this case, I have, in this example, 2 devices. In the demo today, I only have 1. So again, that's what happens. Since you're going to have some kind of wave UI before you connect to Google, and you're going to tell it, hey, here's a new light bulb for my system, for Philips Hue or whatever you're using. You can give it a room name as well. You can pass that information to Google, and if you have a room on your Google Home app, on your home graph, that is named the same, Google is going to place it in that room. If not, it's going is going to ask about it. So this is what you reply to Google. This is however you want to implement it. Any programming language, you need to comply to this format. Basically, I'm telling it, I only have one light. It's called like this, and these are the traits. These are the traits that I mentioned at the beginning. And based off of this, Google is going to present a different UI, and Google is going to be able to fulfill different commands. Like if you don't have the on-off setting, that's kind of a weird light bulb, but Google is not going to let you turn it on or off. So that's what happens on the first link. When you execute a command, like through the UI, pushing that button or talking to Google and telling it, hey, turn the temperature up or set the light to this other color, Google is going to translate that into text. It's going to extract that meaning. It's going to contrast that with your home graph information, and it's going to send you a command like this one. And in this one, you can see it's telling me, hey, set the absolute brightness value to 97. This is, clicking with your finger or sliding. This is what you get. So this is the absolute power of the smart home API. Doing this on your own, it will take you like a lot of time. Supporting a bunch of devices, it will take you an incredible amount of time. Having a UI, it will take you an amount of time that will be, too much to have for a bunch of different devices. With this, you get clear, concise JSON, very easy to parse, very easy to understand. So whenever you're ready, you've executed whatever it is that you need to execute to get to this device. In this case, it could be an HTTP request to a specific IP that I know this is listening to, or maybe you're writing to a Firebase database like we're doing on the workshop. You do that, and then you need to tell Google what happened, if it was successful or not. And it is important that you respect the different error codes that Google has. It might be that the user is trying to talk to a device that is no longer in your system. There's a specific error code for that. If you don't provide enough information, Google is just going to say, something went wrong, which is really, really frustrating. So please do that. With that said, we're gonna go through the demo, and hopefully Wi-Fi didn't disconnect, and this is working. So before I do the demo, any questions? No? That was boring. I'm sorry, it's after lunch. It might be too much. So I'm gonna connect to my phone right here, if it wants to. You should be able to see. I need to purchase the pro version of this. Come on, buddy. No, I'm not using always on top. What are you talking about? Okay. Is this working? Okay, it is. I think you can see it well enough. Yeah, that's super useful. So, for example, this is the home that I was talking about. This is the toy home, and there's a few commands that you can do with all the devices. You can turn them all on or off, or you can go to a specific one. So I have just one room that's called downstairs, although technically it's this one right there. And then I'm gonna go into the light, and I'm just gonna. It is supposed to be off right now. I'm gonna turn it on, and it turns on. Thank you for the applause. So maybe you want to change the color. You have like a very good color picker here. You can do any colors you want. These are just the ones that Google gives you. So you can see it's pretty fast, even on this Wi-Fi. I'm just clicking super fast. And of course, you can talk to it. Like doing this by myself will be a lot of work. But say a weird color. Please name any strange color out loud. Alice blue. Okay, I don't know if he's gonna know that one. Set the light color to Alice blue. I don't think Google speaks CSS, but.
You got it. Changing kitchen to Alice blue.
Well, that's supposed to be Alice blue. I guess he does know about CSS. So this is very useful. You can see there's an integration with the actual assistant. I get a slider here, so if I turn down the brightness all the way down, you can see it's like turning it off. I'm gonna slide it up to 30%. It is very fast. It is very convenient. Providing this kind of user interface for users is really simple. You can use this for like real life projects or just playing on the weekend or whatever. Again, I'm gonna share the code for all of this. There's a workshop that you can follow. You can just buy the materials and go through it. That's basically it. I'm gonna scroll through the end. Yeah, I'm done. So any questions? Over there?
Well, this is a commercial one. Which are the advantages of having a Google Home device at your home rather than using just the phone?
Sorry, the question is, what are the advantages of having a custom device that you made?
No, the Google Home device. I mean, the Google Home rather than only your phone.
Rather than using only your phone. So why wouldn't you just use your phone? Why would you have a microphone in your home listening 24/7? So the audio is very good. I use it all the time to do all kinds of tasks like setting alarms, setting reminders, sending messages to people, although you kind of have to kind of hack it. I didn't say this, please cut this from the video, but you can even do video calls like with the Nest Hub and the Lenovo Smart Display is called. You can even do video calls. So it's just another device that's right there. You don't have to unlock it. You can use it to play music. It sounds great. And I use it like I have a bunch of them through home, so I play music on all of them at the same time, and I just do whatever I'm doing, cleaning the house or whatever. The music is everywhere. So that's one of the reasons. The audio quality, the convenience, it's always there. Sometimes you're out of use on your phone. Sometimes you lost your phone. I use that a lot. Like I say, hey, where's my phone? And it makes my phone ring. I don't have to go to the web interface. So there's a million uses, really. Anybody else?
Thanks for the talk. Right now we have seen the interaction from Google to our home. There is any possibility to report Google the state of the device? Imagine that it's a switch or any way or the way.
Yes, there's a way of doing it. It is in the slides. I was running out of time, so I kind of skipped it. But there is a way that you can report back to Google and tell it, hey, this device changed. So yeah, you can do that. In fact, you are kind of required to do that. They say in the documentation that home graph, when Google asks you about they sync, they have like a list of devices, but they don't save the state. They say they only save the state of the stuff that you report proactively. I don't know whether to believe it or not, but if you are listening, for example, if you're using local tunnel like I was and running your API locally, you will see Google hitting you and making query requests for the devices that you've told it that you had. So you are kind of required to, be proactively updating Google about that. There's one here.
My question is that I didn't get it. The devices that you're using at your home have to be already in the ecosystem of Google Home, or you can get something like different technologies and put them together. I'm thinking about devices that have Z-Wave or all of the ones that work with YouTube or Wi-Fi. How do you put all of these together?
Yes. So that tells me I did a very bad job in my presentation. I'm sorry. No, basically what you're asking is how do you connect the Google part with something that connects through Zigbee or MQTT or whatever other mechanism. That is entirely up to you. What you need to provide for Google is an API. That is the part that I showed you. You get this JSON in, you have to reply with this JSON out. However you do it in the background, like you might write to a document database, put something in a queue, put something in PubSub, send something through MQTT, or send something through Zigbee somehow in your system. You need to have that line of communication with your devices. So that is a very implementation-specific detail. So that's kind of why I stepped over it. In my case, what I'm doing here, and what you see in the workshop, I just have a Firebase database with a document for the light. When Google tells me to do anything, I update that document in Firebase, and in here, I'm running a Firebase client for Arduino, And when something changes, this gets a notification. And I get told, hey, the light changes. Now it's on this color, and I just update that. So for me, that communication between the platform and your API, it is entirely up to you. The part that's important is how you communicate with Google, because there's only one way to do it. It's using this protocol that we saw here today. One more there.
Correct me if I'm not saying correctly. Okay,
you're wrong.
I guess this
sorry.
public API. I mean, I guess this API has to be public.
Not really. It can be. I mean, it's not public. You need to authenticate. You give credentials to Google. If nobody else has the credentials, nobody can do anything. So
okay, but it has to be exposed on the internet, so actions on Google can reach it, right?
Yes. Yes.
And what do you think about all that? I mean, there's now technology that allows you to do all this offline instead of doing it online. Do you think Google has anything on the roadmap that will try to approach this in different way and offline?
So there's the local home SDK that you can use to do stuff offline. We can talk more about that after we're done. But yeah, you can do stuff offline. It's kind of limited, but they are working on that. In the Google I/O this year, they did a presentation where they did a bunch of commands using the Google Assistant, and then they showed, by the way, I'm using airplane mode, and everyone was like, "Wow!" So now that is a direction that they're much moving on, and connecting with devices. That's where the Smart Home SDK it's aiming for, really.
Thank you.
No problem. Are we good? Okay, if you have any more questions, send them on Twitter, find me later, or send me pictures of cats or whatever. Thank you very much.